Today we are on the back of the 7th set of notes. Do not worry about the top part of the notes from yesterday. We are not going to be doing that, so we are going to be strictly on the back side of the 7th set of notes for today. So the top of the paper, there's two bullets, and it kind of talks about the conjugate root theorem. And the conjugate root theorem just is implying that if I have a square root in my answer, there's always a positive and there's always a negative version of an answer. And again, you do not need to write this down, it's at the top of the paper, but all it's saying is if I have an a plus the square root of b, well, that means it's implied I need to have a minus the square root of b. Similarly, with an imaginary answer, the only time we get an imaginary answer is if I take the square root of a negative value. So that means if I have a positive I also have to have a negative I. And we're going to be using this idea today because I'm going to give you the answers or the roots of a problem, and your goal will be to create the equation that it came from. So keep this in the back of your mind when you're given roots. There's always a positive and negative version of square roots and of imaginary. So for the first example, they're telling you it's a quartic polynomial. Quartic implies that it's to the 4th power. Okay, and if it's to the 4th power, that means I get 4 answers. And if I have 4 answers, notice in the problem they're giving you the square root of 2 and 1 plus I are roots. What are the other 2 roots? So based on what we just discussed, if I have a positive square root of 2 as an answer, well, that means a negative square root of 2 is also a root to the problem. Similarly, if 1 plus I is given to you as a root, that implies that 1 minus I must also be in the root, because whenever I take the square root, there's a plus or minus. So here are my other 2 roots. So I would like you to try letter B. Figure out what is the other answer for letter B under example 3. So you can pause the video if you need to try that, or come back to it in a moment. The next example is example 4, and I'm going to do letter B because letter B is the more difficult one of the two. In letter B, the imaginary answer says 2 minus 3i. I want you to cross the 2 out and just make it a negative 3i. So again, this problem is telling you it's a quartic polynomial, which implies we get 4 answers. So notice 3 answers are given to you, so if you want to kind of write it like this, they're telling you that x is 8, x is 2, and x is a negative 3i. So the only other value you have to add to the list is a positive 3i. That was not given to you, but it's implied to be in the list because it's imaginary. From here, we're now going to work backwards, and we're going to set up the binomials that they came from. So if I got an answer of positive 8, that means it came from the binomial of x minus 8. If I got an answer of 2, it came from the binomial of x minus 2. If I have an answer of minus 3i, that means it came from an x plus 3i. And that last one is implied to come from an x minus 3i. So this problem turns into a big foiling or boxing problem. The key is that you always foil together your imaginary binomials, and then you always foil together your non-imaginary. So I'm going to kind of split this in half. And we're going to foil together the right-hand side first, and then we'll foil the left-hand side. So if I foiled the right-hand side, I'm going to do my x times x, which is x squared, x times negative 3i, which would be a minus 3ix. Then we'll have a plus 3ix minus a 9i squared. And if you do the box, obviously you could do the box there. These middle 2 terms are going to be gone, so now I'm left with x squared minus 9i squared. And an I squared, this is going back to quadratic chapter, I squared is equal to a negative 1, so technically I'm doing negative 9 times a negative 1. So this ends up becoming x squared plus 9. So that's what we get from foiling the 2 imaginary components. Now we're going to foil the left-hand side. I'll just do box this time. If you don't do box, don't do the box. Do your foiling method. So I have an x minus 8 and an x and a negative 2, and now we find the inside, so I get an x squared, a negative 8x, a negative 2x, and a 16. When I combine like terms, we get x squared minus 10x plus 16. So I foiled the imaginary, I foiled the real, and now I have a binomial and I have a trinomial. Now we're going to have to FOIL those two results together. So I'm going to switch the screen so I have some more room. So we have this x squared minus 10x plus 16, and I'm multiplying it with an x squared plus 9. So for those of you who do the box, you can do the box here. You're just going to do a 2 by 3. So I'll show you how to set it up. So you would have a 2 by 3. I'd have my x squared, my 9, and x squared, negative 10x, and a 16. So for those of you who do the box, go ahead and find the inside of the box. For people who don't do the box, it's just a big distributing problem. So I'm going to start by distributing x squared to the x squared. So that's x to the 4th. And then we do x squared to the 9. So I have a 9x squared. Now I'm going to follow this process, but now I'm going to do a negative 10x to both. So negative 10x cubed. And then I'll have a minus 90x. Lastly, I'm going to do my 16. So I'll have plus 16x squared. And then we'll have plus, let's see, plus 144. And for my box people, you should have the same terms in your box. Now we just have to combine like terms. So I have an x to the 4th power. I only have one cubed term, so minus 10x cubed. These two terms, my square terms, will combine together to be plus 25x squared. Then I have minus 90x, and then plus 144. So this would be the equation to the 4th power that would match those roots. So that's all for today. We'll pick up with this tomorrow in class.